In this lesson, we are going to have a look at mechanical work and work done. So, to begin with, let's consider what we mean by work in general. Have a look at the light bulb, something you're all familiar with. Try to tell yourself what is the energy change going on in that light bulb. Well, the energy change is from electrical energy coming in through the wires to light and some heat coming out. So the light bulb is changing one kind of energy, electrical, into two other different types, in this case, light and heat. You could say the light bulb is transferring energy from one type into another. And that is the simple definition of what we mean by work in physics. Work is done when energy is transferred. And what we mean by transferred is changed from one type into another, just as the light bulb changes electrical energy into light and heat. It's important to memorize that phrase. It will help you enormously in solving problems later on. Work is done when energy is transferred. Okay, now let's define specifically mechanical work. So this is what we mean by work when we're not dealing with electricity or light or heat or anything like that. We're simply dealing with forces and objects that are moving. So have a look at the shopping trolley. I'm quite sure you've all helped your parents in the supermarket. That trolley is going to be pushed around the supermarket. So if you look at it, you can see there is an applied force, F applied. That's the force placed on the trolley by the person pushing it. And there's also a certain resistance to the movement caused by friction in the wheels of the trolley itself. So you have the applied force, in this case, pushing to the left, and the opposing forces, the frictional forces, pushing to the right. Let's imagine then that we push this trolley a certain distance d, shown by the arrow. Let's see the trolley move that distance d. Here it goes. So we have pushed the trolley a distance d by exerting an applied force, F applied, to that trolley. We're now going to define the work that we have done in moving that trolley. I'm sure you would agree that if you're pushing an object for any length of time, it does use up energy. So you are transferring energy from yourself to the movement of that trolley. If you're transferring energy, you're doing work. Remember the key phrase, work is done when energy is transferred. We're going to define the work done, the mechanical work done in moving an object then, very simply as this. EW stands for energy transferred or work done. So the W is the work bit and the E is the energy transferred. So that equation reads work done equals applied force times distance moved. Let's be clear on the units. If the applied force is measured in newtons, as it should be, and the distance moved by the object is measured in meters, then the work done will be in joules. Work done equals applied force times distance moved. Two things to note. In this equation, it is the applied force that we're using, not the unbalanced force. Notice that friction doesn't come into the equation at all. We don't actually need to know how big the friction is. All we need to know is how big the applied force is, and we're going to assume that it's constant. Second thing to note, it's the distance moved, d, in meters, not the displacement. If you think about that, if you were to go round the entire supermarket pushing the trolley and come back to where you started, your net displacement would be 0. That would give you the impression that you might have done no work if you put displacement into the equation. So it's very important you don't put displacement into the equation, you put in distance. Let's now look at a worked example and you'll see how it works. It's quite easy. Okay, here's an example. Imagine Nicholas is at the supermarket and he pushes his shopping trolley with a force of 50 newtons. If, on going right round the supermarket, he covers a distance of 300 meters, how much work has he done? Well, as always, to begin your solution, you must list the variables. EW, that's what we're looking for, so that's question mark, that's the work done. The applied force is 50 newtons, and the distance moved is 300 meters. State the equation. Work done is force times distance. 50 newtons times 300 meters. Nicholas has done 15,000 joules of mechanical work. And that's all there is to it.